My dear students, welcome to my channel, The Science Academy. Narayan Chandra Mozumdar, lecturer in physics, Rajuguttura Model College, Uttara Model Town, Dhaka. I will discuss today on class 10, subject physics, and chapter 9, refraction of light. Today's learning outcome is you will be able to tell what is the ray diagram of lens and how is image formed in lens, the nature of image in lens for the different position of the object, because I have discussed in my previous class what is lens, how many types of lens, and the different quantities regarding lens. I mean, what is optical center, principal focus, principal axis, etc., center of curvature, radius of curvature, etc. I have discussed in my previous class. That's why today I am doing this. So first of all, ray diagram for convex lens. This is the lens, and the first law is when light falls parallel to the principal axis, after refraction, think that there are two principal focus, f1, f2. After refraction, the light passes through the principal focus. This is the first law or first ray diagram. And then after this, when light passes through optical center, this is optical center, light does not change its direction when it passes through optical center. That is the number 2 rule. And when light passes through optical principal focus, just like this, then after refraction it will be parallel to the principal axis. That is the 3 laws. I am repeating again. The ray diagram in convex lens. First up lens, I will draw the principal axis. This is the lens, and this is the optical center, principal focus 1, principal focus 2. The first law or first ray diagram is when light falls parallel to the principal axis. After refraction, it will pass through principal axis. Number 1. Number 2, when light passes through principal optical center, it will not be deviated. it will not change its direction. And number 3, when light passes through when light passes through that is the 3 laws. Now when light passes through principal focus, after refraction it will be parallel to the principal axis. That is the 3 laws. So there is the number 1, number 2, there is the number 2, and number 3, this. So that's from my side of ray diagram in convex lens. So we may write in this way: ray diagram for convex lens when light rays incident on the lens parallel of the principal axis, then after refraction refracted rays passes through the principal focus, and when light passes through number 2, when light ray passes through the optical center, then the ray does not change its direction. Number 3, when light ray passes through a principal focus, then after refraction refracted rays become parallel to the principal axis. My dear students, can you hear me? Now the ray diagram for concave lens. So this is the principal axis for concave lens, and this is the concave lens drawn here. This is optical center, number 1 principal focus, number 2 principal focus. Number 2 principal focus. So in this case, when light rays falls parallel to the principal axis, after refraction it will pass through, it will diverge in such a way that it seems to come from the principal focus, and this is the number 1. And when light rays passes through the optical center, it does not change the direction, similar to the convex lens, number 2. And number 3, is when number 3, when light ray falls towards the principal focus, after refraction it will be parallel to the principal axis. That is the ray diagram for concave lens. So finally I am drawing again because very easy way, that is the optical principal axis, that is the lens, this is optical center O, principal focus 1, principal focus 2. Now the ray diagram number 1, when light ray falls parallel to the principal axis, I mean this way, it will diverge in such a way that it seems to come from principal focus. That is the number 1 ray diagram. Number 2 ray diagram is when light passes through the principal optical center, it does not change its direction. That is number 2. And when light passes through the principal focus, I mean if you extend this line, it seems to go through the principal focus. After refraction it will be parallel. That is the ray diagram for concave lens. So already we have learnt about what is the now we'll write the how we write when light rays incident on the lens parallel of the principal axis, then after refraction, refracted rays diverge in such a way that it seems to diverge from the principal focus. Number 2, when light ray passes through the optical center, then the ray does not change its direction. And number 3, when light ray passes through the principal focus, then after refraction, refracted rays become parallel to the principal axis. That is the ray diagram for concave lens. My dear students, now position of image for different position of object. In a short way, very short way, think that this is the convex lens and this is F, I mean principal focus. This is the position of 2F, and again opposite side principal focus, I mean the distance from the optical center, focal length, and this is the 2 focal length, twice of focal length. So we may identify in it is simply number 1 position is indicate the position in infinity, and number 2 is the position between 2f and infinity. Number 3 is the position of the body at the distance of 2 focal length 2f, and number 4 is the position between f and 2f, and number 5 is the position at the focal length, I mean at the principal focus, and number 6 is the position between focal length and optical center. And in opposite side, this is the 6, 5, this is 5, this is 4, this is 3, 2, 1. So when you place the object and this is the image position. When you place object at position 1, then image will be formed at 6 minus object position, that is 5. And when you place the object at 2 position, image will be formed 6 minus 2, that is 4 position. Similarly, when you when you place the object at the position 3, then the at the position 3, then image will be 6 minus 3, that is 3. Object is situated at position 4, then image will be formed 6 minus 4, that is at position 2. When object is placed at position 5, image will be formed at 6 minus 5, that is equal to 1 position, I mean in infinity. 6, then 6 minus 6, that is 0, and 0 position is the position. In this case, virtual image will be formed, and the side where image will be formed at the side where the object is placed, I mean object position and image position will be in the same side of the lens. So now we will do some practical knowledge, we will practice something. Okay. Now finally, I think that object at position 2, then image will be formed, that is the f 2f, and this is the 2 position, this is 1 position, 3 position, 4 position, 5 position, 6 position. This is F to F, F to F, and this is 6 position, 5, 4, 3, 2, 1 position. So when you place the object here, then image will be formed here, this here, because image will be 6 minus 2, that is at 4 position. So first of all, draw the ray diagram from parallel ray, and after refraction it will pass through the principal focus. This is the principal focus, and another ray, when it passes through optical center, it does not change its direction. So the light meet here, that means image will be formed here. This is, so this is the object, and this is the image of the object. So you may practice by yourself for the position of object at different position, and I will practice again. Think that position of the object is at 4 position. I mean this is F to F. Sorry. This is F to F, and it is also F to F. This is position 1, 2, and 3. Now if you place the object, if you want to place the object at position 3, then image will also be at the position 3. So how? We'll draw the ray diagram. First of all, from here, the parallel beam of light after refraction, it is after refraction, the light will passes through the principal focus, and another ray from here, when light ray passes through optical center, it does not change its deviation. Then here the meeting point, so image will be formed here. So when you use the scale, then it will be straight line and it will be clear image. Okay. Now we will four, 5, 6, 6, 5, 4, 3, 2, 1. So now the position object, consider the position of the object is number 4. Then image will be formed at the position 2. So now draw the ray diagram. This is the parallel beam of light, parallel ray. After refraction, the ray will pass through the principal focus, and another ray passes through optical center. It does not change its direction. It does not change its direction. So that is the meeting point. So image will be formed here at the position 2. I mean between infinity and all are real image. Here all are real image, and position is between infinity and between infinity and 2f, twice of focal length. But when you, my dear students, can you hear me? So, but when you place the object at the position when you place the object focal length uh, focal length 2f, focal length 2f infinity. Now if you place the object between the optical center and principal focus, then what will happen? First of all, the ray diagram, when light passes parallelly of the principal focus, it will pass through the principal focus, and again another light, when it pass through optical center, it does not change its direction. This refracted ray number 2 and number 1 refracted ray will not meet to any point, but if you extend the object, if you extend the ray, they seem to divert, they seem to come from the point. Think that this ray. So this is the virtual image. Here the virtual image will be formed. So this is virtual image. When you place the object between focal length and optical center. I will do again this figure because it is very important for you. My dear students, optical center, principal focus, and 2f. We need not mention here 2f. When you place the object between focal length and optical center, then virtual image be formed. How I will discuss here. First of all, a parallel beam of light, parallel ray, parallel of the principal axis. After refraction, it will pass through principal focus. Another ray, when it pass through the optical center, it will not deviate or change its direction. When you extend this two refracted ray in backward side, it will seem to come from this point. This point. So this point, the virtual image will be formed. Virtual image will be in this way. This is the virtual image, and also it is magnified. This is also the working principle of simple microscope or magnifying glass. So virtual image, and when the object is placed between focal length and optical center O. So finally the conclusion is, when you place the object this way, between this focal length and optical center, In this case, virtual image will be formed, but when you place this here, then real image will be formed. So both type of image may be formed in convex lens. It is similar to concave mirror. Concave mirror. I mean, convex lens and concave mirror, they are similar. Similar in the sense of image formation, because in the convex lens both type of image may be formed. Also in concave mirror both type of image may be formed here, but here refraction, but in the case of mirror there will be reflection, image formed by reflection, but here image formed by refraction of light. So probably you understand, my dear students. Now what you learn after this, after my lecture? Rule of ray diagram, image formation in lens, how image is formed, and position and nature and image. But one thing, in the case of now you will do by yourself in this class, what are the ray diagram for convex lens, and find the position of image when object is situated between focus and optical center. I have stated just before, just 2 or 3 minutes I have stated and I have discussed this. So that is the image formation of convex lens, but I have not discussed how image is formed in concave lens. I will discuss later. Your homework is draw the image for the position of object respectively 1, 2, 3, 4, 6 position in convex lens. What is the meaning of this? That means this is the convex lens and it is the focus, 2 focal length. So this is the position 1, position 2, position 3, position 4, 5, 6. For the position, what is the meaning of the position 1? I mean infinity. Position 2 means between infinity and 2f. Position 3 means 2f. Position 4 means between f and 2f. Position 5 means focal length. Position 6 means focal length and optical center. So that's from my side. Thank you so much. I will discuss how to image formed in my next class. Thank you so much. Thank you, my dear students. Thank you.